In 1960, IBM introduced the world's fastest computer. It was called Stretch. The initial price tag was $13.5 million, or over $143 million today. It was IBM's first transistorized supercomputer, originally advertised to be over 100 times faster than IBM's top-of-the-line Model 704 electronic data processing machine. The 704, released in 1954, was the first commercially successful computer to incorporate features like high-speed magnetic core memory and floating-point arithmetic. It was a scientific computer used by NASA, MIT, Bell Labs, the Strategic Air Command, and various other military and educational facilities. The 704 could execute over 40,000 instructions per second. The IBM 704's speed record was chosen as a comparison point, since it was already well known in the industry as a reliable high-speed computer, and IBM had successfully sold over 120 machines. Of historical interest, at about the same time period, IBM had just produced a special high-speed computer for the US Navy. It was called NORC, for Naval Ordnance Research Calculator. The dedication ceremony for the NORC was promoted with significant media fanfare, as seen in this excerpt.
Officials of international business machines and high-ranking naval officers are on hand for the induction of the Navy's newest recruit. It's called the Naval Ordnance Research Calculator, NORC for short, and it's described as the world's fastest electronic brain, never needing a vacation for multiplication. The lady can tell what's going on by watching the numbers, if she doesn't blink.
The machine was installed at Dahlgren Naval Facility in 1955. Although NORC was also a high-speed computer, it was a one-of-a-kind machine built specifically for the Navy's testing facility. It contained 9,800 vacuum tubes and 10,000 crystal diodes, which made it the fastest vacuum tube machine of the time. However, it could not compete with the transistorized supercomputers already in development. By the mid-1950s, the Los Alamos Scientific Lab and the Lawrence Livermore Radiation Lab were seeking high-speed computers, faster than the 704 or anything else available. After considerable discussion, in October of 1954, IBM engineers Werner Buchholz and Stephen Dunhill began drafting a series of papers describing a conceptual high-speed computer they called the Datatron, which would spearhead IBM's position in the data processing field. Numerous internal meetings of top IBM technical personnel that included Dunhill, Buchholz, Gene Amdahl, Wallace Eckert, and many others continued over many months. Eventually, it was decided that a new high-speed computer would be designed, which would be named Stretch, to formalize the concept of stretching the state of current technologies. In 1958, the directorship of the Stretch project was eventually assigned to Stephen Dunwell, a brilliant engineer whose extensive experience included significant work on various IBM calculating and computing machines, and prior top-secret work for the Army Security Agency in the area of cryptography and cryptanalysis. The Stretch design and development was the product of many talented individuals at IBM, and it was a huge financial and personnel resource investment by IBM. Thomas J. Watson, Jr., who had taken over as CEO in 1956, made it a priority for the company. Gene Amdahl had an early involvement on system design, but left IBM after Dunwell was selected to head the project. Others on the team headed by Dunwell included Fred Brooks, John Koch, Jim Pomerine, Harwood Kolsk, Robert Blosk, Gerrit Blau, and others. Some of the advancements implemented in the Stretch were incorporated in later IBM machines in the coming years. The machine used over 169,000 transistors in total. One of the innovations employed in the Stretch design was the SMS card for standard modular system to help facilitate the massive number of transistorized components. The SMS cards could be easily swapped out for testing or replacement. The Stretch used over 22,700 SMS cards in total, which included over 18,700 single SMS cards and 4,000 double-wide cards. Card technology began to be phased out with the introduction of the smaller, more efficient solid logic technology, or SLT components, introduced with the System 360 family of computers in 1964. Early IBM promises regarding the Stretch were complicated by the fact that the machine was still being built. Later, the Stretch computer's advertised speed estimates were sometimes compared with IBM's new 7090 machine of 1959. The 7090 or 7090 utilized 50,000 transistors and magnetic core storage and had a price tag of under $3 million. Testing at Lawrence Radiation Lab indicated Stretch was only 5 times as fast as the 7090, instead of the 8 times faster anticipated. IBM's Watson was highly embarrassed and offered a price reduction from the high of $13 million to about $7.8 million. But it still claimed the spot as the fastest computer in existence until Control Data Corporation's 6600 machine arrived 4 years later. In the following film, Dunwell himself describes the Stretch and gives a high-level overview of the machine's design, including a scale model of the entire system.
Ladies and gentlemen, this is the Stretch computer nearing completion at Poughkeepsie. I thought that you might like to see a model of the machine so that you can have a better idea of how it will look when it's installed at the Atomic Energy Commission Laboratory at Los Alamos. Stretch is the fastest, most powerful computer in the world. At this moment, the computer circuits are performing more than 1 billion operations every second. This is the main section of the machine. As you can see, the main section is divided into units in which many different data processing tasks can be going on at the same time. To make sure that each part completes its function at the proper time, we have designed an entirely new computer capability which we call the look-ahead. This device looks beyond the work being done in the machine to anticipate what is required next. The look-ahead then assigns tasks to the various machine elements. Stretch has 6 main memory units. Each of them has a capacity of 16,000 words. They operate in 2 millionths of a second. To further increase the speed of the machine, it is arranged so that all 6 memories can operate at the same time. In addition to its main memories, there are 2 specialized memory units. One of these, the index register memory, is able to read out at a tremendous rate, in 4/10 of a millionth of a second. In order to carry information in and out of the machine with maximum efficiency, we have this specialized computer called the exchange. It carries the information from the mainframe through to the input-output devices. The lights give a panoramic display of what is going on within the exchange. Stretch includes many error-checking devices to ensure that it is operating properly. In addition to this, there is an automatic error correction device which in many cases makes it possible for the machine to correct its errors and to continue on without interruption. In developing Stretch, we've used new kinds of transistors, about 170,000 of them. The transistors and their associated circuit elements are contained on these cards, which facilitate manufacture and repair. And now I'd like to take you to see the operator's console. The lights permit the operator to ascertain the course of the job being performed by the machine. Switches make it possible for him to vary the course of the computer. The typewriter is provided for the input and output of small amounts of information. In addition to this, we provide magnetic tapes, card readers, card punches, and the IBM chain printer for high-speed printout. In the short space of time that we have been doing the Stretch machine, it has performed over 100 million complex mathematical operations. This is more work than could have been accomplished in this space of time by 75 of the large-scale computers now in our customers' offices.
The following news excerpt from 1962 announces the IBM Stretch computer delivered to the United States Weather Bureau.
Here, Weather Bureau scientists are testing mathematical models of the Earth's atmosphere. Now, with the IBM Stretch computer, they have a tool powerful enough to take the complicated equations and simulate how the Earth's weather really behaves, all within the computer. This contour map generated by the Stretch system represents surface weather over the northern hemisphere. It also represents a major step to advance man's understanding of why the atmosphere behaves the way it does.